All right, welcome back, everyone. This is our last recording for Unit 1. So here we are sharing our screen, and we're going to talk about our next part. Okay, here we are. We are on page 21 of our notes, talking about our normal distribution and z-scores. So the last part of our statistics talk. So here we're talking about a normal distribution curve. So when we're talking about our population, we're talking about a normal distribution. So when we're doing a survey or they're collecting data on us, the more data they collect, the more normal our curve is going to be on us. I want to show us a depiction of what's going on so we can kind of get a general idea of what's really happening with this curve and what's going on. So let's see if I have it here. Okay, so we're looking at really a histogram. And usually with our data, it depends on how much data we have. So if we have a small amount, it's going to look a little choppy. The more data that we add until we get to 100% or the entire population that we're talking about, the more data we add, the more normalized our curve gets. So here we have a depiction of a number of men. We're looking at their heights. So if we look at a random sample of 100 men, and these are the results of their heights, you see how big and choppy our results are in this histogram. If we increase the size of the number of men that we're talking about, we get more heights, we see that those bars get a little smaller and it kind of gets just a little more normal, a little more straighter, right? We increase the size a little more, right? The sample size continues to increase. Again, it gets just a little more smaller, it gets a little more even, and it gets a little more what we call normalized. Until we get to the entire population of adult males. So we say we talk with everybody and we get all their heights, then everything starts smoothing out and becomes symmetric, right? And becomes what we call our normal distribution or our bell curve. So that's what we're going to be looking at in this particular section. So we're looking at what we would consider looking at our entire population or 100% of our population and looking at this normal distribution curve, all right, this symmetric curve talking about 100% of our population, all right? All right, so let's go back. So here's our normal distribution curve. Percent of pencil. So the percent of the population, okay, is the area, okay, under the curve. I'm actually writing that pretty good. Okay, but not talk too soon. Okay, under the curve in decimal form. Make myself laugh. All right, so the entire area underneath our curve here, all right, so the entire area here, all of these areas, you add all that up, and that, right, area is 1. Or in other words, or 100%. Okay? So that's what we're talking about, 100% of our population. Now, as you see with our normal distribution curve here, that things are symmetrical. If you split this right down center, you can fold it in half, so it's equal on both sides. If you think about a number line, we've dealt with that a lot, right? So when you're labeling a number line, you start in the middle, you have 0, and then you have your positive numbers going to the right, you have negative numbers going to the left. So you have 0 in the middle. 0 in the middle is going to represent our mean, okay? This is our mean. So whatever our mean is, that's where we're going to start. So I'm just going to write this as mean. Okay. Then above the mean, you have your positive numbers. So we have 1, 2, 3. And these lines represent below the mean. So you have negative numbers, -1, -2, and -3. These values right here are called z-scores. Okay. These are called z-scores. We're going to look at z-scores, and this is going to tell us how many places above or below the mean certain data values fall. And we're going to talk a little bit more about that on our second page. Okay? These things with our population, so we're talking about 100% of our population, these things are broken down into percentages, we said, right? We know it's 100% of our population, but each one of these intervals represent a percentage of that population. And we call this the 68, 95, 99.7 rule. This right here, you're going to need to know, right? But don't worry, you don't have to memorize it. It's nice if you do, but I'm going to give it to you on the test to help you remember. Here's what it looks like. So here we have our three curves. So this first part here, 68%. When we are underneath our curve, remember, this is our mean, right there. 1 standard deviation above and 1 standard deviation below. So our z-scores represent standard deviations above and below the mean. So when we go above, we add. When we go below, we subtract. So here, label 1 and -1. So when we are talking about 68%, this area right here, here and here, okay, underneath the curve, represents, okay, this area. Within 1 standard, this is kind of small. Didn't give me enough area to write. I'm gonna rewrite it. So this, I'm gonna write it over here. Okay. All right, STDEV, standard deviation. Okay, remember that we learned that on our last recording. So 1 standard deviation represents of our population. Okay, 68% of our population is represented within one standard deviation of our mean. That's one above and one below, trapped in between those two numbers. Okay? When we look at two standard deviations, so we're going here. So remember, this is our mean. So we're talking about two standard deviations above and go below. So we're talking about right here in this whole entire area here, trapped in between -2 and +2. Okay, all of that under there. We're talking about our population. This is represented by this 95%. So this area right here, okay, this represents 95% of our population. Okay? So 95% of our population will fall within two standard deviations of our mean. Then our last part here, 99.7% of our population will fall within 3 standard deviations. So if we were looking under our curve, remember this represents 100%, but if we were looking at the area that represents 3 standard deviations, remember our mean again is in the middle. We're talking about all of this area now, all these people here. All these people. All of these people make sense. Looks like that's almost 100%, right? This represents the 99.7% of our population, this area. So this represents 99.7% of our population. Now remember, I didn't color in these little tidbits on the sides there. You see that? All right, I didn't get there yet. So that's why it's 99.7%. Are we all right so far? Take and absorb this. This is some really good stuff. You don't have to remember it off the top of your head, because I'm going to help you remember by giving you this rule right here. So you'll know 1 standard deviation, 2 standard deviations, 3 standard deviations of your mean. Now, another way to look at this is actually looking at these areas underneath the curve that are broken down. So those percentages broken down based on these areas. See this right here? These are your percentages underneath the curve. This right here, you don't even have to memorize that, because I'm going to give this to you as well. All right? So, all right, this will be on the test. All right? What we have to do is know what to do with them when we need them. It's going to be simple. We just need to add. Here's what's happening. If this is 68% of our population, which is 1 standard deviation of our mean, okay? And this is symmetrical, right, amongst this line, then it is reasonable to know that half of 68 is 34%, right? So you have 34% here and 34% here, and that represents your 68% of your population. That's all we did. We just simply took and found the percentages for each one of these areas underneath the curve. I'm not going to ask you to do this because we've already done it for you. Remember, it's symmetrical, so I'm only going to give you half of the curve, and then you'll know that the other half is exactly the same. Here we are filling it in so you'll know what it looks like. You're 34. I'm going to go to the right first, and then I'll come back and do the left. This is 34%. Right. Your next area here is 13.5. Okay. This next area here breaks down into 2.35%, this area right here. And then the last part, this little tidbit right here, is 0.15%. Okay. Now we're going to go the other side. Now there is no negative and positive because we're talking about percentages, right? So we're just underneath the curve. We're not here with our z-scores. So don't get that confused. So here we are, we're labeling our second half. So this is 34. Then here we said it's 13.5. This is our 2.35. Okay, right here. And this is our 0.15. Right here. So these are all the areas broken down underneath the curve and their percentages. When we add all these up, that's your 100%. So we can look at it as our standard deviations. One standard deviation, 68%. Two standard deviations is 95%. Three standard deviations is 99.7%. Or we may need to look at it in broken down pieces for each area underneath the curve. And here's our individual percentages that represent those areas. We're going to see how we're going to use this in just a second. All right, so again, I'm going to give you this information on the test. You'll just have to know how to label it yourself. So study this labeling. All right, now let's see how we're going to use this. It says, build the normal distribution curve. If our data had a mean of 60 and a standard deviation of 10. So you're always going to get a mean, and you're going to get a standard deviation. Why? Because we know that the mean is always going to go in the middle. That's what you're building off of, right? So they're going to give you that. So our mean is 60, that goes in the middle. The standard deviation tells us how our data is dispersed, right? So we know that we're going to disperse it by going in increments of 10. Above the mean, we're going to add. Below, we're going to subtract. So as we move up, right, we're going to add 10. Go up, we add 10. We go up, we add 10. As we go down, we subtract 10. Subtract 10. As we go down, we subtract 10. It's just like our real number line. All right, here we go. We're starting at 60. If we add 10, we should get, that's right, 70, and then 80, and then 90. That's right. Now let's go down. So if we're going down, 60 minus 10 gives us 50, and then Okay, and then 30. Good. All right, so now we have our data values. These are not z-scores. Our z-scores are always going to be these values up here at the top. They will always be 1, 2, and 3, -1, -2, and -3. Okay, don't get that confused. These are data items. Okay. So these things right here, data items. We just created those things ourselves based on the information that they gave us. Okay? Now, we know how to construct our own normal distribution curve. Let's see what we're going to do with it. What do they want us to do with it? Okay? All right, using problem 10, we just did it. They want us to answer these questions. Find the percentage of the population above 60. Now, remember, this is our graph. These are the values that we got. So we may want to transition this over so we can make sure we remember. So remember, 60 was our mean. 60, okay? They want to know what is the percentage of the population above 60. So above 60 would be all of this right here, right? All of this, all the way down to that little tidbit, okay? So what amount of percentage would this be of our population? Wouldn't this be half of the graph? So that'd be 50%, wouldn't it? That's right. 50%. Don't think too hard about it now. Here, we're telling the keyword above. So we know that we're going to go above in the positive direction. They didn't tell us where to stop or it was between anything. So we know we were going to go above on forever. So we're going to take and look at that whole upper part of the graph. That was half of the graph. We know it's symmetrical. Okay? Let's look at the next one. Remember, this is 60. Okay? They want to know what is the percentage between 50 and 70. So if this is 60, we know that this was 70. And this is 50. And they want to know what is the percentage between these two. So they're talking about this area right here. What is the percentage represented here? Now that looks like just our one standard deviation. And what does one standard deviation represent? 68%. Okay? Do you see what we're doing? Based on what they're asking us, we're going to look at the graph, and then we're going to just simply tell them the percentage of our graph, of our population, that represents that interval or amount that they're asking us for. And this is where our knowledge of the percentages, whether there be the rules or just a breakdown of our percentages underneath the curve, right? That's where we're getting this information. Then it says, find the percentage of the population above 80. So if our mean is 60, that means that this is 80 right here, right? So above 80 would be this part and this little tidbit right here. Now, if we remember our breakdown of our percentages, I keep going back so we can take a look. We're talking about this area right here, this part, and this little tidbit part. So these two percentages, we're just going to add those two together, and that's going to give us our percentage. So we have 2.35 and 0.15. Take your calculator, add those up. So we have 2.35 plus 0.15, and that is going to equal what? Should be simply 2.5%. You don't have to worry about changing this to some type of fraction or anything. You're just keeping it just the way it is. All right, so 2.5%. Okay, and our last one here, below 30. So here, below 30. Now we need to remember where 30 is. So if this was 60, this was 50, 40, this was 30 right here. But we're talking about below it, so that little tidbit right there. So what's the percentage of this piece right there? That's right, 0.15%. All right. So being able to be familiar with our percentages, I suggest that you label your graph first so that you can always refer back to it so you can remember what the percentages are, right? Okay, let's look at z-scores, our standard normal distribution. So they're going to ask you some questions about what is z-scores, the z-scores for those particular data items. Here's our graph. I'm going to bring it up a little bit and see if we can. Okay. Here is our problem, and we have a formula that helps us calculate our z-score. Here's the z-score equals the data value minus the mean, all divided by our standard deviation, right? Lots of times you can just look at your graph. So if you have to draw the graph, you can find out what the data, the z-score is just by looking at your graph. But then there's going to be sometimes you're not going to be able to tell because it's going to be in between, and it's going to be really hard to determine what those percentages or decimal points are. So hence, you're going to need to know how to use your formula. Let's construct our graph so we can see what's happening. So the problem reads, suppose the test scores for a particular class are normally distributed with a mean of 70, so there's our mean, and a standard deviation of 10. Let's find the following. So they gave us our mean and our standard deviation. Here we are filling in our table, right? Here's our graph. We know that 70 goes in the middle. Now we know that we're going to disperse it or go ahead and use our standard deviation of 10 to create our intervals. So 70 adding 10 will be 80, then 90, then 100. Then subtracting going down from 70, we have 60, 50, and then 40. Okay, so we've filled in. We see where our data items are. Now we can see about answering some questions. It says, what is the z-score for the data item or value of 85? Now, when we look at our graph here, we see that we have a space for 80, we have a space for 90, but not 85, not directly. But if this is 80 and this is 90, it's logical that 85 would be right here in the middle. Do we agree? Okay, so if this is 85 here, we now have to remember that our z-score, which z-score would this be? So remember, the z-score is the numbers that represent these intervals here going above or below the mean. So I'm going to put those in right underneath. So here are my z-scores. Okay, and you can do this after you finish filling in your normal distribution curve with your mean and your standard deviation spread. Underneath, you can go ahead and put in your z-scores so you can remind yourself. So we have -3, -2, -1, 0, 1, 2, and 3. Now we've just reminded ourselves of our z-scores. So they're asking us, what is the z-score for the datum item or value of 85? So if 80 is the z-score of 1, then 85 must be 1.5. Do we agree with that? Because it's halfway in between. So we say 1.5. We also know it's going to be positive because it is above the mean. And above the mean is positive. So 1.5. Now, let's use the formula so we can see how the formula is going to work. So if we're looking for the z-score for this data item, here we are plugging in. We know what our value is we're looking for, which is 85. So what you would do, here we're looking for z-score for 85. You're going to take and plug in your value is 85 minus your mean. The mean is 70 divided by my standard deviation, which is 10. So here is us using the formula to verify what we saw on the graph. Now you don't have to do both. I just want to show us so that we can see what's really happening and that you have options. You can use your formula, or if you see it on your graph, that's good. Here we are. Let's do the math. So 85 minus 70 gives us, remember, if it's going to be positive, it's positive. It's going to be negative, it's negative. So we have 15 divided by 10 simplifies to 1.5, which is what we saw on the graph. All right. Okay, now let's look at this next statement. It says, what test score is 2 standard deviations below the mean? So now they give us this mathematical statement, and they want us to see how we're going to use this information that we've just done in order to find out. Remember back in algebra, we would have these information that they give us in a statement form, and we'd have to transition it into a mathematical statement. We're going to do the same thing here. Look at the key words, and we're going to see how we're going to write this. We're going to start at the back of our statement and work backwards, okay? That's what we're doing. We're looking for X, because it says, what is the test score? That's our X. X equals, right? Because equals is. And we're not necessarily working backwards, but sometimes when we're writing it, sometimes you may have to write things a little invertedly based on the wording that they give us. So let's watch this. What test score is 2 standard deviations? So 2 standard deviations below the mean. So right here is where we're going to do that inverted thing I just said. So you're going to have the mean, right? And then this word below. So what's our mean? 70. Below means subtract. Remember, above means add. So below means subtract. So 70 minus, and then it says 2 standard deviations. So 2 standard deviations would be 2 times standard deviations. What's our standard deviation? 10. All right. So let's look at it one more time. We're looking for the test score, X. And here's our statement. What is our test score? All right, that is 2 standard deviations below the mean. So our mathematical statement is going to be what the mean is. They gave us the word below, so we know we're going to subtract what from the mean? 2 standard deviations from it. So 2 times whatever our standard deviation is. So that was 10. So 2 times 10. So when we do the math, we have 70 minus 20, and that is 50. There we are using the mathematical statement. Could we have found this off of the graph? Let's take a look. What test score is 2 standard deviations below the mean? We go to the graph. Here's our mean, 70. 2 standard deviations below, we would go 1, 2 standard deviations, and our value right here, 50. So we see it right there on the graph. So there's times that your graph is going to be so helpful, it's going to give you the answer right off the bat. There are going to be times that you're going to have to use your mathematical knowledge to kind of finagle and write your equation that's going to get your result. Let's try the next one. What is the test score that is 2 standard deviations above the mean? Let's look at the graph and see if that'll just help us. What test score is 2 standard deviations above the mean? Here's our mean. Remember, above means to go and add above, right? So we're going above. So 1, 2. That number, 90. It did it for us. But what if we couldn't see it? Let's practice writing our statement. So we're looking for x. X is that number. What is the score? All right, the test score is that it's 2 standard deviations above the mean. Again, that keyword above the mean. So when we're writing our mathematical statement, starting at the end and working our way backwards, our mean, 70. Above means to add. So plus 2 standard deviations, right? So 2 times all right, times 10. So now we have 70 plus 20 equals 90. There's our verification. Does everybody see what we're doing? Again, constructing your graph might be your saving grace, but being able to have that knowledge of writing out or using our formula, that can help us, okay? All right, our next one. What is the z-score for the data item or value of 70? All right, let's go to the graph. So they want to know what the z-score is for the data item of 70. 70, that sounds familiar. Well, look at here. 70 is our mean. All right, what's the z-score for that? 0, right? Okay, so the data, the z-score for that data item of 70 is 0. It's our mean. Okay, the mean is always going to be 0 for our z-score. Okay. Again, you could use the formula to find it. Let's look at the next one. What is the z-score for a data item of 60? All right. Give you a minute. Take a look. See what you can find out. I think I see it. Okay. All right. So we're looking for that z-score that represents the data value of 60. When we go to our graph, we see 60, and that z-score that represents it, -1. right? Remember again, we can use our formula for z-scores just to make sure that we're okay. Looking at what they're giving us, they're asking us for the z-score, okay, for 60, right? So the data item they're given, 60 minus our mean of 70 divided by our standard deviation of 10. When we subtract 60 minus 70, that gives us a negative 10 all over 10, which reduces to a negative 1, which is what we clearly saw on our graph. All right, last one. Says what test score is 2.5 standard deviations above the mean? So again, we're looking for a test score, right? X equals. That is 2.5 standard deviations above the mean, above, right? Now, let's see if we can figure it out by looking at the graph. 2.5 standard deviations above the mean. So here we are, the mean, 2.5, let's go, 1, 2.5 would be right here in the middle, and that represents 95. Is everybody all right with that? Okay, we say it's 95. Let's see if the math, the equation, verifies it. Writing our equation, the mean, which we know is 70. We're going above, so remember we got to add, plus 2.5 standard deviations. So 2, I'm going to put 0.5. This will be a little easier to put in your calculator. 0.5 times our standard deviation of 10. And then when we do our math, we get 70 plus 2.5, okay? And when we multiply 2.5 times 10, that just moves our decimal place over once, and that gives us a whole number of 25. So that gives us 70 plus 25. And that added together gives us 95. It verifies. Yay. Okay? So you got options. Sometimes, and most times, doing your graph will answer your question. But if it doesn't, and it gets in that weird spot where you can't figure it out, you got a formula to back you up. Now, I won't give you this on the test. You have to know the z-score formula. Now, I don't know. If I just decide to give it to you on the test, then you'll be surprised. But go ahead and memorize this, okay? All right. So we've gone through all of our lessons. Now you're ready to go ahead and finish up your homework and begin your studies very shortly with your test review for this weekend. So have fun, work hard, and if you have any questions, I'll see you in the office. All right. Have a good one.